Welcome students to the numericals of refraction through a lens. It's a very important part of numerical year with respect to your board examination. At least one numerical is compulsory to come from this lens part. So pay proper attention, try to understand it properly. So first of all, we will take a look at the formulas which are there, which will help us in working it out. But in this lens chapter, numerical, just the formula will not help you out in doing it. You have to know properly the sign convention where a positive and where a negative sign will be used with each of these physical part, that is the object distance, image distance, height of the image and height of the object. So first we will take a look at the formula and then thoroughly go to understand the sign convention properly. Once that sign convention will be clear to you, you will be able to do the numerical very easily. So let us first start with the formulas. So first of all, we will have a formula relating the focal length, object distance and the image distance. So that first formula is 1 by f is equals to 1 by v minus 1 by u. Do remember what they stand for. So to not to be confused, I will write here u stands for object distance, v stands for image distance and f stands here for focal length. So first this formula will be used, then we come to is the magnification. Magnification means how many times is the image compared to the object. So this is the relationship between the height of the object and the height of the image. So based on that, you get the formula as height of the image divided by height of the object. So here we are coming across these m, which is magnification. Then we have O, which is height of the object. I will be height of image. So those things which we have come here related it. And now another formula for magnification is v by u. It means at what distance the image is from the lens divided by at what distance the object is kept from the lens. By this formula also you will get the magnification. Then you know we can also have that power of the lens. Power of the lens you have studied is the reciprocal of the focal length, and at that time the focal length has to be taken in terms of meter. So you come across P is equals to 1 by f. I am writing in the bracket meter to confirm to you that remember you should take that focal length in meter while calculating the power. Okay, and the unit of power, this first of all I will write here power. P stands for power of the lens and unit of P in full spelling it is DIOPTRE, diopter, but when you are writing in symbol it is to be written with a capital D. So for doing the numericals you will require all these formulas. Kindly take a note of them. Then now we will move on to the sign convention and see in which case which one will have what sign, whether positive sign or negative sign. So now let us come to the sign convention, and on the basis of sign convention we will be able to decide U, V, I, O, F will be getting positive sign or negative sign in different cases. I have taken three particular specific ray diagram. First ray diagram is about convex lens where the object is between f1 and 2f1. So you know the way to draw the diagram, and then you get a real image formed beyond 2f2, where the size of the image is bigger than the size of the object, and an inverted image is formed. Another ray diagram I have taken where the object lies between the optical center and the focus, and you get a virtual image formed which is bigger in size and it is erect. So one place we are getting a real image, one place virtual image, which will help us in deciding whether a real image and a virtual image will get a positive sign or a negative sign. Then I have taken this one is a concave mirror with the object being placed over here, and here also we get a virtual image but smaller in size, it is erect. So we will see the sign convention what they are, and on that basis we will conclude the sign for U, V, F, I and O. The first rule of sign convention says that any measurements which is to be done has to be started from the optical center towards the quantity to be measured. It means what? Like if I have to measure the object distance from O to A, for measuring the direction to be followed is from O to A, not from A to O. Same way, if I have to find the image distance, I have to go from O to A dash. And if I have to measure the focal length, I will go from O to F2. And we will be taking F2 because from F2 we are taking the rays which are parallel is going from through F2, not through F1. Okay. So first rule says all measurements from the optical center to the thing which is to be measured. Second one, very, very important one, the measurement which is done in the direction of the incident ray has to be taken as positive, and if it is against the direction of the incident ray, it is to be taken as negative. And to make it clear, this is my arrow showing the direction of the incident ray. This arrow will help you to understand that if the measurement we are doing by going in the same direction as the arrow, we should take it as positive, otherwise it is to be taken as negative. I hope the second rule is clear. Now the third one tells about the height of the object and the height of the image. Any height which is above the principal axis will be taken as positive, and below the principal axis will be taken as negative. So this is a very simple one. And if you have done coordinate geometry, you will easily be able to relate why in such condition positive and in the other condition negative. If you have x-axis, y-axis and x-axis drawn, you notice which side you write positive numbers, which side negative number, and on that basis only it is based here. So let us take a look at what signs will be there for each one of them based on the rules. So we start with object distance, that is U. So let us take object distance here. So I have to go from O to A, so in this direction, which is against that arrow. So U in this case is negative. Let us come to the next diagram where you are getting a virtual image, but we are looking at object distance. So I have to go from O to A, again going towards this direction, which is against the direction of the incident ray. So it is to be taken as negative. Here also it comes as negative. So whether a real image is formed or a virtual image is formed doesn't make any difference. U for convex we have seen till now is coming as negative. Let us see what happens in concave. Again the object is here. So O to A will be going against the direction. So it means we conclude that U is going to remain as negative always. It means what? The moment you get object distance given, whatever is the value given, write a negative sign with it. So if the numerical says object is placed at a distance of 25 centimeter, you will write U equals to minus 25 centimeter. So I will write a conclusion here that U is always negative. Okay, U is always negative. So remember that. So this word always I am underlining. So always start with taking U as a negative sign. Okay, now let us come to the image distance. Here we have a real image formed. So to measure the image distance, I have to go from O to A dash. It means going in that direction, which matches with the arrow direction. What type of image you have here? Real. And what are we getting going in that same direction? So positive. Okay. So I will say that whenever a real image is formed, the sign of V will be positive. So I will write here V is positive for real image. Okay, so for real image we know. Now let us take a look at virtual image. We have virtual image at these two conditions. So I have to measure from O to A dash, the image distance. So I have to come in this direction, which is against that arrow, direction of the incident ray. So it means virtual image will be in negative. Okay, so I will write here V is negative for virtual image. So you know for V also now. So remember in mind, if you are given this information that the image is real and the value is given, thing for example as 20 centimeter, you will have to take V as plus 20. But if it is told it is a virtual image, then you will be taking it as negative sign. Also remember, in the numericals, many a times it will not be told the image is a virtual image or a real image, but an indirect information will be given. You know that real images are formed on a screen. So if it is mentioned to you that the image is formed on a screen, indirect information that the image is a real image. So like this, you should be able to pick up from the numerical informations which are given. Now let us come to the focal length for convex. So I have to go from O to F2, O to F2 going that way. So it means it is in the direction of that arrow of the incident ray. So focal length for a convex lens will be positive. So the third thing coming, F for convex lens is positive. Okay, F for convex lens will be positive. So both the case you can see that we have to go for measuring focal length from O to F2 going that direction. Now let us say take a look at concave lens. O is here, F2 is here, so you have to come towards this direction against the direction of the incident ray. So for concave, focal length will be taken as negative. So I will write here F for concave lens is negative. So now you have got the signs for object distance, image distance and the focal length. So we are done with U, V, F. Okay, now let us take a look at I and O. For any measurement above the principal axis has been told to be taken as positive and below the principal axis as negative. Okay, so object we always place, okay, above the principal axis. So I will say O is always positive. O is always positive. And image can be erect, can be inverted. You know it very well that if you are getting a virtual image, image is erect. So erect image will be having a positive sign. So it means moment we are getting virtual image, I will be in positive. But you know that real images are always inverted. So when you get a real image, height of the image will be taken as negative. So we go to write on that basis I for Real image I am writing first. So real image will be negative, and I for virtual image is positive. Okay, so we have seen all the signs which will be required for working out the numericals. Again, I repeat, just taking the values given the numericals is not enough. You have to put a sign. It will have a plus sign or a minus sign. Read the question, understand it, and put the sign, and then just it will be a simplification sum. Apart from this, a very important thing is the sign which you get for magnification. So, how does the sign of the magnification and the value of the magnification decides what? This is a very, very important part to be understood. So, pay attention properly and get it. Now we will be calculating, so I am just writing here magnification. This will be specifically about magnification. Okay, so we can get the magnification, the formula which I had told, either by V by U or by I by O. So magnification will have a magnitude as well as it will have a sign. Magnitude and sign will decide upon the nature of the image. Okay, so first of all, I am writing here if m is greater than 1, it is greater than 1, then we will have, then image is magnified. So whenever you calculate m, it gets greater than 1, it is magnified. Please remember here that we are looking at the magnitude here, not the sign. So m is greater than 1, it will be magnified. Second condition in this, if m is less than 1, okay, then image is diminished. Okay, it means the size of the image will be smaller than the size of the object when m value comes as less than 1. Okay, so number will decide upon whether it is magnified or diminished. Now, the sign of it, okay, if m is positive, if m is positive coming in plus, then image is erect. Okay, it will be erect image you will be getting, like you have got erect image over here as well as here. So it will be an erect image. Then the last one coming here, if m is negative, okay, then, so remember this is a negative sign, not a dash, is negative, then image is inverted. Okay, image is inverted. These are four very, very important things. It will help you a lot. So you should remember this. I suppose the magnitude and the sign, what they are deciding is clear to you. Now, just to check out whether your understanding is clear or not, think you go to find the magnification in a numerical and think you are getting the calculated as -2. So if the magnification value comes as -2, what information will you get from about the image? So take a look like this. You can think of the answer and listen to what I am telling now and try to see whether it matches with your answer or not. So you separate them. Minus is different and 2 is different. So the magnitude 2 you take a look. Don't take a look at magnitude as -2. Negative has a different role to play here. So if it is 2, it means it fits this category. So it is greater than 1. So I will write about the image that it is magnified. Okay. Now I will take a look at the minus sign. It is in negative. Negative is for inverted. So it is magnified and inverted. Like this, to take a look with the result which you get from magnification. Okay. I hope all these part has been understood. Kindly take a proper note of this. Write it in your notebook and mark it as very, very important. With these informations only you will be able to work out the numericals. And if you remember all the sign rules, okay, and the sign which I have explained here, numericals, you will find it very easy. So next we will proceed to the numericals. Now we begin with the numerical of this very important exercise. Okay, I hope you have gone through the sign convention, because all those sign convention part will be utilized here. So let us begin with the first one. At what position a candle of length 3 centimeter, so the candle length is given, means the height of the candle is given, height of the object is given, is placed in front of a convex lens so that its image of length 6 centimeter, height of the image is 6 centimeter, can be obtained on a screen placed at a distance of 30 centimeter behind the lens. Something hidden information is there, try to get it. This part, okay, image is formed on a screen. Which type of image is formed on a screen? A real image is formed on a screen. So the sign for V will be based on what we have for real image. You try to recall, when I write the value, I'll put the sign there. So let us go. This 3 centimeter is the height of the object. So I write here O equals to 3 centimeter. O is always positive, so written there as 3. Then it is told the image has a length of 6 centimeter. So I will write I as 6 centimeter. Now pay attention. I had told that the image is formed on a screen. A real image is formed on a screen, and the real image is always inverted. So I will get a negative sign. All these only we have to pay attention to in these numericals. Let us see ahead. At a distance of 30 centimeter behind the lens, the image is formed at a distance of 30 centimeter behind the lens. So the V value is given to you as 30 centimeter. V for real image is positive, so written here as positive. We are asked to find what is the place where the object will be kept. I is known, O is known. Magnification can be calculated. Magnification again is then related with the image distance and object distance. So I can write both the formula of magnification and relate it. So I will write here M is equals to V by U and then equal to I by O. And then I will substitute the value. So V is plus 30. You can write that plus sign, don't write also, will not matter. U we have to find, equals to I is minus 6. You will have to write minus sign, okay. And O is plus 3, so written 3. So this will get cancelled. So U will be, minus 2 will come and divide here. So you get it as minus 15 centimeter. So your U value is minus 15 centimeter. With this negative sign coming whenever you calculate U, confirms that your working is correct. Okay. Now the B part says what is the focal length of the lens in part A. So for focal length, 1 by F equals to 1 by V minus 1 by U. So 1 by F copied, 1 by V was plus 30, so written minus 1 by U, U is minus 15, so written here. So LCM will be 30, so 1 minus minus is plus, 15 2s is 30, you get this, 2 years. So F will be equals to 30 by 3 is equals to 10 centimeter. So F coming as 10 centimeter means plus 10 also confirms that it is a convex lens, and in the question also it was told that it is a convex lens. So you come to know clearly that both your answers are correct. Hope you have understood with this sum how to apply the signs which are there. You put the signs correctly, so numerical is very easy. So now we move to the second numerical, which say the concave lens. Okay, a concave lens forms the image of an object kept at a distance 20 centimeter in front of it. So this is the object distance 20 centimeter. U always has to be taken as negative, so U will be written as minus 20 centimeter. Image is formed at a distance 10 centimeter on the side of the object. So where object is there, on the same side the image is there. It means it is a virtual image, and virtual image will be given a sign of negative. So V will come as minus 10 centimeter. What is the nature of the image? Already told, virtual image will be formed. Okay, let us take a look here. The distance here is 10 and there it is 20. Whenever a virtual image is formed, you know it will be erect. Okay, and if we find the magnification by doing V by U, okay, you will come to know that it will be diminished. Okay, so first of all we go to write the nature. So we will write image is virtual. So the moment it is virtual, we go to write erect, and this is a concave lens. So if you are perfect with your ray diagram, without calculation also you will be able to know and write there directly that a concave lens forms a diminished image. So you can write here diminished. So this part is done. Okay, now you are asked to find the focal length of the lens. So for that, first of all, let us write the value. 20 centimeter is the object distance. So U is equals to minus 20 centimeter. Then image distance is 10 centimeter. We know it is a virtual image, so it will be minus 10 centimeter. So we have written the sign. We have to find the focal length, write the formula and substitute the values. So 1 by minus 10 minus 1 by minus 20. So LCM, we will not take the negative sign in the LCM. So 10 and 20 LCM is 20 is known. There is a minus, so 20 divided by 10 is 2. So we will be writing here minus 2, and here it will become minus minus plus 1. So it means I will be getting F is equals to 20 by minus 1, which is equals to minus 20 centimeter. Focal length coming in negative makes it clear to you that it is a concave lens, and the question had concave lens. So the working is correctly done. Again, I will repeat, please pay attention to the signs which are being given. Signs are done correctly, numericals are absolutely easy. Let's see the next numerical, and a very important type of numerical. Okay, so pay attention and get the clarity of this numerical. The question is like this: the focal length of a convex lens is 25 centimeter. At what distance from the optical center of the lens an object is to be placed? It means we have to find U we have to find, object distance U we have to find to obtain a virtual image of twice the size. Value, if you look in numbers, it will seem that only that focal length is given, and we are asked to find the object distance. A very important information is this twice part and this virtual image. Twice is the value of the magnification, and this virtual image will tell you what sign magnification will get. Virtual images erect, and so erect images taken as positive. So this magnification which will be there has to be taken as positive. So very important information comes here. Okay, that is a hidden information which I was telling you. Will have to crack that part. So let us do the working. First of all, focal length convex is told. So f is equals to plus 25 centimeter written. Now magnification I will write is twice is 2, and because virtual image is told which is erect, so I will write here plus 2 and show. Now I know magnification formula is V by U. So for here I will write plus 2. So V by U. So I get V is equals to 2U. Because I have to find the object distance, so I have found V in terms of U. Okay. Now I will write the focal length formula. 1 by 25. Now V will be written as 2U. A very important thing to be remembered, we have got V equals to 2U. Now you don't think now U has to be kept in negative. I will put a negative sign there. That will become wrong. You cannot do that. You have got V as twice of U. So you will put there 2U. And now this U will be written as it is. Again, I repeat here also, don't do the mistake. U has to be negative, so I'll put a minus sign. The formula will become wrong. Now simplify it out. So I write here 1 by 25. LCM will be 2U. So 1 minus 2 will come. So I get here 1 by 25 equals to minus 1 by 2U. So U will come minus 1 into 25 by 2. 25 divided by 2 will give you 12.5. So you get minus 12.5 centimeter. Again, see that U has come in negative. So it means you are correct. U has to come in negative. So object has to be placed at a distance of 12.5 centimeter. But where? In front of the lens. Okay. So I will write here object to be placed at a distance of 12.5 centimeter in front of the lens. So this very important numerical is done, and hope you have understood it. So we come to another very important sum similar to the previous one, and you will get to learn another very important thing in this numerical. So let us go through the numerical, which says, where should an object be placed in front of a convex lens of focal length 0.12 meter? We will convert it into centimeter, which you know is 12 centimeter, to obtain a real image of size 3 times the size of the object on the screen. So previous sum was virtual image, now it is a real image. So real image means inverted image, and inverted image means magnification will be in negative. So this part is the main important part in the last sum as well as this sum, to get the sign of the magnification correctly by taking a note whether it is a real image or a virtual image. This sum could have been also given without mentioning this real image, but it will be told it is formed on the screen, and on screen what type of image you get? Real image. So you have to be alert for all these while reading the question, and always a good habit to underline the important thing in the question so you don't miss out on anything. So let us work it out. So first of all, we will write about the focal length. So focal length, it is convex, so it will be positive. It is 0.12 meter. I will write it as 12 centimeter. Then we come to magnification, which is told 3 times. So 3 written. It is told real. So again I repeat, real is inverted. Inverted image magnification is in negative. So I write here minus. So now I will write magnification is equals to V by U. It means minus 3 is equals to V by U. So I get here V equals to minus 3U. Because we have to find object distance, so again I am finding V in terms of U. So now write the focal length formula. Focal length is 12 centimeter. 1 by V will be put as minus 3U minus 1 by U. So 1 by 12 equals to LCM 3U. So I will get a minus 1 here, minus, and I will get a 3 here. So I write here 1 by 12 equals to minus 4 by 3U. So U will come. So I am going to take this U this side. So minus 4 into 12. 12 goes from here. 3, this will cancel it. So I get U as minus 16 centimeter. So this object should be placed at a distance of 16 centimeter in front of the lens. So object to be placed at a distance of 16 centimeter in front of the lens. So I hope this sum has been understood. Okay, very important. You should know how to find the sign in case of magnification, and they will mention to us in some way whether it is a virtual image or a real image, and that only will help us to get it. So now let us come to numerical number 5 and try to understand this question properly. An illuminated object lies at a distance of 1 meter from the screen. So that 1 meter will take it as 100 centimeter. So are you taking that U as 100 centimeter? Take a proper look. Is that U given to you 100 centimeter? Let us read it again. An illuminated object lies at a distance of 1 meter from the screen. Object is 1 meter from the screen. It is not object distance, it is the distance from the object to the screen. So let us take a look in the diagram. So if I say here is the screen, this is the screen, and I am taking the object to be here. The object is here. This distance is given to you as 100 centimeter. So this has to be understood. Mainly in this numerical, everyone takes that U as 100 centimeter. Let us see further what happens. A convex lens is used to form an image of the object on the screen. So a convex lens will come there and the image will be formed on the screen, placed at a distance of 75 centimeter from the lens. From the lens, the screen is at a distance of 75 centimeter. So let us put a lens here. This is the lens. This distance is 75 centimeter. So lens here, object here. Object distance will be 100 minus 75. That will give you 25 centimeter is your object distance. So this question was to be understood properly. Now the sum is very easy. So we have to first of all find the focal length. So let us put all the values here. So I will write here U equals to 100 minus 75, 25 centimeter, and put the sign also with it. It will get a negative sign. Then V is given as 75 centimeter. Image is formed on the screen. So it's a real image, and V for real image is positive. So you can write a plus sign or leave it like this. And now let us go to find the focal length. So formula written, let us substitute the values. 1 by 75 minus 1 by U. So U is minus 25. So I will get 1 by F. LCM will come as 75. So 1 here, minus minus will become plus. So 3 here. So 3 plus 1 will be 4. So I can write F is equals to 75 by 4. So you go to divide 75 with 4 and on dividing you get 18.75 centimeter. Okay, so you get the focal length here. Now second part is asked to find the magnification. So m is equals to v by u. So v value was 75, u value is minus 25, divided you get minus 3. What does it mean? Minus tells that the image will be inverted. We had a real image, so it had to be, it is formed on the screen, real image, so it had to be inverted, and so negative sign has come, and value coming as 3 means it is a magnified image. We are not going to write that because the question did not ask us to tell about the nature of the image. It only asked us to find the magnification. So this numerical is done. So we now come to the fifth numerical. Follow the question properly, and as I am reading the question, you are also reading it. Try to get the sign as you are reading the question, and then see whether when I explain whether you are correct or not. A lens forms the image of an object placed at a distance of 15 centimeter in front of it. Object distance is 15 centimeter. It will be written as minus 15. At a distance of 60 centimeter in front of it, image is formed at a distance of 60 centimeter in front of the lens. So V is 60. What's the sign? Sign is negative. Did you get it correct? Why negative now? Image is formed in front of the lens. It is a virtual image, and virtual image V sign is negative. So if you take the sign properly, you can get the focal length easily, the magnification, and based on the magnification, we can tell about the nature of the image. So let us start working it out. So we come to the first part. So let us first write, we have seen u is equals to minus 15 centimeter. V is equals to, given at a distance of 60 centimeter in front of it, virtual image, so minus 60. Now we can proceed to find the focal length. 1 by f is equals to 1 by v minus 1 by u. So that will be equals to 1 by minus 60 minus 1 by minus 15. So 1 by f equals to LCM of 60 and 15 is 60. So 60 dividing by 60 is 1, but there is a minus sign, so minus 1. Minus minus will become plus. By 15 you divide, you get 4. So f is equals to 60 divided by 3. So you get it as 20 centimeter. So focal length came as plus 20 centimeter. For focal length, plus sign is in which case? It is in a convex case. Did the question tell us about which type of lens it was? No. Can we tell the lens also? So we can tell it is convex. So let us write here convex. Now second part is to find the magnification. V by u. So V is minus 60. U is minus 15. Both the negative sign cancel. 60 divided by 15 is 4. It means you are getting it as plus 4. Okay. So plus 4 means it is an erect image. 4 greater than 1 is a magnified image. Okay. And erect image is virtual. So now you can tell the nature of the image. So I will say first of all virtual. Okay, which we anyhow we came to know without the calculation part of magnification. Virtual plus means it is erect, and 4 means greater than 1, so magnified. So hope you have understood it. Okay, take the signs properly. Sum is easy. So we move on to numerical number 7, and you will find that because we have covered up mostly all the important type, you will be able to understand how to work out the sum simply when I am reading the question and explaining it to you. So let us see a easy one. A lens forms the image of an object placed at a distance of 45 centimeter from it on a screen placed at a distance of 90 centimeter on the other side of it. So the screen is placed at a distance of 90 centimeter on the other side of the lens, and object is kept 45 centimeter in front of the lens. So U is 45, V is 90. Okay. Name the kind of lens. So see, the image is formed on a screen, means it is a real image. And when real image is formed, only one type of lens forms real image, and we know that is convex lens. So we get the answer for the first one. Focal length, as we have been finding, we'll put the value, solve it and get it, and then we can get the magnification. So let us go to work it out. Okay, so 7a, okay, already explained why we have to tell that it is a convex lens. So convex lens. Okay, then the B part of it, to find the focal length and the magnification. So let us write first U, which is minus 45 centimeter. V is 90 centimeter. Because it's a real image, so real image V is positive. So let us write the formula and work it out. 1 by 90 minus 1 by minus 45. So 1 by F is equals to 90 LCM, 1 minus minus plus 45 2s are. So I will get F equals to 90 by 3 is equals to 30 centimeter. With F coming as plus 30 also confirms that it has to be a convex lens. So this is the A. First part is done here, and now coming to the second part, which you will also be able to find it out. Magnification V by U. So V value is 90, U value is minus 45, and you divide and you get minus 2. So magnification coming as minus 2, minus means inverted and 2 means it is a magnified image. Nature is not asked here, so we finish the sums here. Let us now come to numerical number 8. Go through the question quickly. A convex lens forms an inverted image of the same size as that of the object, which is placed at a distance of 60 centimeter in front of the lens. So the image which is formed is of the same size as the object. So if height of the object and the height of the image is same, you get magnification as 1. And if you are thorough with the ray diagram, you will know that the image and the object height is the same when the object is placed at 2f. Okay, so object is placed at 2f1, image is formed at 2f2. So size of the object and the size of the image is same. So what is asked? Find the position of the image. So in a way, location I have told you, but at what distance we will find it when we calculate. And the focal length of the lens we have to find. If V and U are known, we can get the focal length. Okay. So first of all, magnification is given as 1, and because it is a convex lens, okay, the image will be formed will be real. So if it is real inverted, so magnification comes as minus 1. So I go to write here magnification as minus 1. So now I go to write V by U is equals to minus 1 for magnification. I have written there the formula of it. What is given to us? The object is placed at a distance of 60 centimeter. So I will write here V and object distance. So minus 60 minus 1. That will give me V coming as 60 centimeter. So if object is placed at 60 centimeter, that location I told was 2f1, image at 2f2 has to be 60 centimeter, and it is on the other side, so it has come as plus, so that shows that is a real image is being formed. So this answer, the position of the image, okay, it is formed at a distance of 60 centimeter from the lens on the other side. Okay, so image is at 60 centimeter on the other side of the lens. Okay. Now we have to find the focal length. So let us write the formula. 1 by f is equals to 1 by v minus 1 by u. Let us substitute the values. So 1 by 60 minus 1 by minus 60. So 1 by f is equals to 60 LCM, 1 minus minus plus 1. So I will be getting f as equals to 60, 1 plus 1 is 2, so 30 centimeter. So the focal length also you have got it. Getting the focal length in plus confirms the lens is convex lens. So now let us come to numerical number 9. Again a very important sum. Let's see what the numerical says. A concave lens forms an erect image of 1/3 the size of the object. So 1/3 of the size of the object, so it means that is magnification. Erect image is told, so magnification will be in plus. Is placed at a of object is which is placed at a distance of 30 centimeter in front of it. So object distance is given to you 30 centimeter. You have to find the position of the image, means V you have to find, and the focal length of the lens. Okay, so let us come to it and write here magnification equals to 1 by 3. Again I repeat, erect image, so I will write it as plus. Okay, then this one is given to us, object distance is given to us, so u is equals to minus 30 centimeter. So I will write magnification formula V by u. For magnification I can write 1 by 3, V I have to find, and u is minus 30. So I get V is equals to minus 30 by 3 is equals to minus 10 centimeter. See, it was a concave lens. V has come in negative, means it is a virtual image, and a concave lens forms a virtual image. Always verify your result in this way, what we have studied in the ray diagram. Okay, so we have got this part, the position of the image. So I will write it, image is at 10 centimeter in front of the lens. Okay, always try to write the position in words. Okay, it will be better. Now to find the focal length, this we had working was A part, B part, writing the formula. So 1 by f is equals to, V came as minus 10, minus u was minus 30. So 1 by f is equals to, LCM taken is 30. So minus 3 minus minus plus 1. So I will be getting f equals to 30 by minus 2 minus 15 centimeter. So f is minus 15 centimeter, minus means it is a concave lens. Did the question tell us? Yes, concave lens. So again verified, okay, that we are coming to the correct result. Now we come to the next sum. Next few sums are absolutely very easy. You will be able to work them out mentally, but still I will write and show it. And it is based on power of a lens. Remember, power of a lens is 1 by focal length, where focal length should be in meter. So next few sums will require this only. The power of a lens is +2 diopter. Find its focal length and state the kind of lens it is. So let us get the focal length, see the sign of it, and we can tell the type of lens. So we will write here P equals to 1 by f. So power is given to us +2, 1 by f. So f will come as 1 by 2. This is coming in meter. So I am writing here into 100 to convert it into centimeter. So dividing we get as 50 centimeter. It was with plus sign. So I write here focal length coming in plus is of which one? Convex lens. So we get it here as convex lens. So the type of lens also we have told. Now coming to question number 11, express the power with sign of a concave lens. Remember, concave lens focal length will be negative, of focal length minus 20 centimeter. So focal length is 20 centimeter, which I will be writing as minus 20 centimeter. We have to find here the power. So the focal length should be brought in meter. So I will write here minus 20 by 100, which will give me minus 1 by 5 meter. So now power is equals to 1 by F. So 1 by F is minus 1 by 5, minus 1 year, 5 year. So you get as minus 5 diopter. So minus 5 diopter is the power of the lens. Minus means it becomes concave. So I will write here, it is concave lens. Okay. So we were told concave lens, that was not required. So but I wrote it there now. So we have got the power there. Okay. Let us come to the 12th one and see what the numerical tells us here. Okay, find the focal length of a convex lens. Now focal length of a convex lens is given to us 25 centimeter. Express its power with sign. So focal length is given to us, we have to find its power, and with the sign, convex lens will be positive, so the power will also come in positive. So first of all, we go to write here that focal length is 25 centimeter. Because it is convex, so let us put a sign of plus. Okay, and let us convert it into meter, because we have to find the focal length. So it will come as plus 1 by 4 meter. So now power is equals to 1 by F. So 1 by F is 1 by 4, 1 year, 4 goes here. It is in plus sign, so I get plus 4 diopter. Okay, so power with the sign we have written. So these are very easy one. 13th one is again a very similar type sum. Let us go to that 13th one. The power of a lens is minus 2 diopter. Find its focal length and its kind. Okay. So power is given to us as minus 2. So I write the formula directly. P is equals to 1 by F. So minus 2 is equals to 1 by F. So I will be getting here F is equals to minus 1 by 2. This will be giving us the answer in meter. So if I want to convert it into centimeter into 100, and so I get here as minus 50 centimeter. Coming there minus means it is, we have to tell their kind, it means it is a concave lens. So I go to write here concave lens. So these are easy numerical, but you should know them because they can be asked in your MCQ questions. Now let us come to question number 17 here, which says a concave lens, okay, of focal length 30 centimeter. Concave lens focal length 30 centimeter, F to be taken as minus 30. Find the position, it means V, and magnification of the image. So V and M we have to find for an object placed in front of it at a distance of 30 centimeter. So object distance is 30 centimeter, and you have to state whether the image is real or virtual. Once you get the value of V, you can comment upon this. So we write here first of all focal length, okay, minus 30 centimeter, very important, you forget that minus and results will be wrong. And then object distance is 30 centimeter, U to be taken in minus. So we know now F and U, we will go to find V by using the focal length formula. So 1 by minus 30 is equals to 1 by V, we have to calculate this, and this is minus 30. So 1 minus 1 by 30, this will become minus minus as plus. So when it comes this side, it will become minus 1 by 30 equals to 1 by V. So 1 by V will be minus 1 by 30, minus 1 by 30 is minus 2 by 30, minus 2 by 30. So this will get cancelled, 15. So we get V as minus 15 centimeter. So V coming in negative makes it clear that the nature of the image is virtual. So it was told real or virtual. I can write that answer over here only as it is virtual. Okay, so we have got V and we have told about the nature also, which was asked. Now we have to find magnification, which you all know is a very easy task. V by U. So V came as minus 15, U was minus 30, negative sign cancelled, 15 twos are, so you get magnification coming as 1 by 2, and I will write a plus sign also. Okay, plus sign makes it clear that it is erect, virtual image will be erect. Half means it is a diminished image. Coming to numerical number 18, so let us take a look at it. What the question says, find the position and magnification of the image, means V and M, to be found out of an object placed at a distance of 8 centimeters. So U is 8 in front of a convex lens of focal length 10 centimeters. So F is 10, convex lens, so plus 10. Is the image erect or inverted? Once we get V value or to say M value, we can comment whether it is erect or inverted. So let us come to this. So first of all, we go to write U as minus 8 centimeter and F as 10 centimeter, which is in plus. Okay. Now we have to first of all find the position. So let us write the formula. 1 by V minus 1 by U. So 1 by 10 is equals to 1 by V minus 1 by minus 8. So 1 by 10 minus minus will become plus, and plus 1 by 8 coming this side is minus 1 by 8 is equals to 1 by V. So I will write 1 by V equals to LCM of 10 and 8 will be 40. 10 fours are minus 8 fives are. So I will be getting V as 40 by minus 1. So I get it as minus 40 centimeter. So image should be placed 40 centimeter in front of the lens. Image is formed, not placed, is formed 40 centimeter in front of the lens. So this is done. Now we need to know the magnification also. So magnification is V by U. So V value we have got as minus 40, U was minus 8. So you get it as 5. And coming in plus 5, so that tells you the image is erect. Okay, so I will write here image is erect. So this sum is done. I had missed these 3 numericals, so we will cover up these 3 also and then wind up this exercise. Okay, so let us take a look at the 14th one and 15th one. They are similar type and a very easy sum. The magnification by a lens is minus 3. So M value is given to you minus 3. Name the lens and state how are U and V related. Magnification minus and it is 3. So minus tells it is inverted. 3 tells it is magnified. Inverted image and magnified is obtained only in case of a convex mirror, because concave mirror will not form any inverted image. So first of all, we can tell that the lens is a convex lens. So lens is convex. Okay, and then how are U and V related? So let us write the magnification formula. So this is given as minus 3. So V and U written, cross multiply, V is equals to minus 3U. So I have written V in terms of U. If anyone writes U in terms of V also, it is correct because it is just told how are U and V related. So we can complete this 14th one. 15th is also a similar type. Okay, so it says here now the magnification of a lens is plus 0.5. Okay, plus means the image is erect. Now erect image is formed by a convex lens also as well as a concave lens. So you have to be careful and look at the value also. Magnification is 0.5, less than 1. It means it is a diminished image. Okay. In convex lens, when it is erect image, it is magnified. But in concave lens, when it is erect image, it is diminished. So the lens here is concave. So lens is concave. Okay. Now, how are U and V related? So same way. So M is here plus 0.5 and V by U. So V is equals to plus 0.5 U. So a two similar type of sums is done here. To the 16th one, in a way this becomes the last sum because 17th and 18th are already done. Question number 16 says a photographer needs a lens with focal length 0.2 meter for close-up shots. Means want to take it a close shot close to the object. The focal length is 0.2 meter. What is the power of the lens required? So we can get the power by this formula which we have done earlier. It has a part here, how does a lens with higher power affect the focusing capability of a camera? Power is more. So when power is more, you know that focal length will be less. It will be a shorter focal length because power and focal length are inversely related. Now imagine if you have a lens with a short focal length, you can focus on nearby objects clearly and get a clear image with a stronger clarity in it. So greater the power, you will be able to take the closer picture in a much better way. Okay, so we will first find the power of the lens. So 16th one, F is given to us as 0.2 meter. Good, it is in meter, I need not convert it. So P will be equals to 1 by F. So 1 by F means 1 by 0.2. If I remove the decimal, 10 by 2 gives me 5 diopter. So power is 5 diopter, and for how does a higher power will affect the focusing capability? So I will write here higher power means short focal length. With short focal length, nearby objects image can be obtained with more clarity. Okay, and remember this higher power means short focal length because focal length and power are inversely related. With this, we come to the end of this very important numerical with respect to the board exam. Please remember to like my video, comment upon the video, and if you need a particular sum to be solved which you're finding difficult, write it in the comment box, and also to subscribe the channel and share it with others. Thanks for watching.